Hello, so welcome to another video. This is Dr. Beck. We're going to look at some GCSE chemistry, and we're going to look at full detail of how things called giant ionic lattices are produced. In a previous video you may have seen we've looked at how to describe a giant ionic lattice, but now we're going to take it even further and go right back to first principles and use a structure to help you answer these questions. So today then, describing the formation of giant ionic lattices. Our question, taken from a GCSE past paper: describe how sodium fluoride is formed from sodium and fluorine atoms. It also says give the formulae, which is the plural of formula, formulae of the ions involved. So there's a lot there. Describe how sodium fluoride is formed from sodium and fluorine atoms. Give the formulae of the ions. Wow, so we've got to turn atoms somehow into ions and then describe how sodium fluoride is formed from those atoms. We have a template to show you how to do this, and this is at the bottom of the page in our booklet. So first thing we should do in this order is to draw an atom of sodium and an atom of fluorine. Then we've got to think about what's going to happen to those electrons. Then we should draw a sodium ion. We'll discuss how we can draw that later. Don't forget to include the charge, because that's part of it. Give the formula or formulae of the ions involved. The second ion is the fluoride ion. Don't forget to include the charge and indeed the extra electron. Okay, so we've got an extra clue there. Write out the two ions as symbols. What structure is formed from the ions formed? How are the ions arranged? And what holds this structure together? Okay, there's our template. I'll refer to the template as I'm going through this. So our question is about sodium fluoride, and we're given a clue that we're going to need some sodium atoms and some fluorine atoms. So again, turning to our periodic table, we see this sodium and we see this fluorine. By now we should be used to this. We have 11 protons, therefore 11 electrons, and they're arranged in these shells. We should know by now we can have these shells 2, 8, 1, a group 1 element with 1 electron in its outer shell. And then we also have fluorine. Sorry, I beg your pardon, this is wrong. It should be 19, 9, my bad. 19, 9 fluorine. And we're going to use a different symbol for these electrons. They're still all electrons, but they are electrons. 2, and this time this one is not going to be filled. Got 6, 7, 8, 9. So immediately, if we're thinking, we're thinking, well, that's pretty simple. I know what's going to lose an electron. I know what's going to gain electrons. So this one will lose its only outer shell electron, and that will transfer to the outer shell of the fluorine to make it have a charge. So we're going to rub out that outer shell for the sodium. We don't need it, there's nothing in it. And we can make sure that we are drawing our ions diagrams. Remember, there was a clue. Draw the fluoride ion. Do not forget to include the charge and the extra electron. So there was the clue. Let's go for this one. This is sodium, but it's not an atom, it's an ion. It's lost a negative electron, therefore will become 1 plus, positively charged. This is not a plus sign, even though I just said plus, this is positive. So apologies, this should be positive, not plus. Here we have the maths minus symbol, but it's not really a minus, this is a negative charge. We have gained a negative electron, this becomes F minus. So write out the two symbols, beg your pardon, the two ions as symbols. Well, there we go, to Na and F. Na plus, Na positive, F negative. Right. What structure is formed? Well, these are ions. We're going to have an ionic structure. And these things are going to be attracting each other. We are going to have a giant ionic structure comprising alternate positive. Now I could say just sodium ions, but I could write Na plus sodium ions and negative F minus fluoride. Remember, we changed the name for non-metals. We changed the name from the atom to the ion. We changed the ending. Fluorine becomes fluoride. The negative fluoride ions which attract each other and are held by strong electrostatic forces. There we go, and that's our answer. We've covered all the things we needed to do. We have named the ions. We've described how they are arranged and described why they are arranged like that. And we've described how sodium fluoride is formed. Okay, on the next page, you can now have a go in a similar way at the questions we see at the top of the next page. And again, there are lots of hints and clues. However, we're starting with a few clues, then less clues, then fewer and fewer and fewer, until down here we're down to actual past paper questions. Okay, we're probably not going to get that done today, but let's see how far we can get. So use my ideas, use the clues, gradually reducing the number of clues, but the principle remains the same. So have a go at number 43, 44, and 45, and if you're working a bit faster, have a go at the next three, and for those of you who want an extra challenge, complete all the way down to below question 50, please.